Hello, this is Ms. DB, and in this video we're going to discuss Chapter 1, Section 7 on simplifying expressions. Our objectives are to use the commutative, associative, and distributive property to simplify expressions, and also we will combine like terms. So the commutative and associative properties of addition and multiplication allow us to rearrange an expression to make it easier to solve. That's the point of learning this. It's to make problems easier to solve even if you don't have a calculator. The commutative property says that you can add numbers in any order. You can also multiply numbers in any order. So here's some examples with numbers. Here's some examples with algebra. 3 times 9 is the same as 9 times 3. AB is the same as B times A. It works for both multiplication and addition. The associative property says that you can group numbers in different ways. So if you're only adding or only multiplying, then you can change the grouping. You could do 6 plus 8 first, or you could do 8 plus 2 first. In the multiplication example, you could do 7 times 4 first, or you could do the 4 times 5 first. There's advantages to grouping so that you can mentally add or multiply. Like 8 plus 2 is 10, so 10 plus 6 is 16. That's quicker than doing 6 plus 8, possibly. That's pretty easy too. And then adding 2. And in this one, if you group the 4 times 5 together, that's 20. 20 times 7 is 140. So you can change the way you're grouping in order to make it easier to add or multiply in your head, which is what this is. All right, so here we have 1/3 times 5 times 33. So if you take 1/3 times 5, that's 5/3. That's not very easy to work with. But if you take, sorry, I'm trying to grab my pen here and it's not showing up. If you take the 1/3 times 33, those, here we go, 1/3 of 33 is 11. So then you can do 11 times 5 and get 55. So you're able to do it without even using a calculator. In this example, look for ways that we could group this to make them easier to do. Like I know that 16 plus 4 is 20, and then maybe you can do 45 plus 55, that's 100. So the answer is 120. But you can rewrite them next to each other, and then you can group them like this, and then you can get that your answer is 120. So when you're solving these problems on your worksheet, you can do what I just did and do it in your head. That's the whole point of using the commutative and associative properties. Or if you're not so sure how you're supposed to do that, put the ones that look like they're going to be easy to add together, rewrite them next to each other, and then rewrite the other ones next to each other. Okay, we also need to use the distributive property. The distributive property is when you have multiplication and addition. There'll always be a number on the outside of the parentheses. Sometimes you'll see it written this way with the number on the back side of the parentheses. That's still the distributive property. And the distributive property says that you can multiply this number 3 by each number inside the parentheses. And then because this is a plus, we would add those two products together. So A parentheses B plus C means AB plus AC. A times B plus A times C. So this works with subtraction as well if subtraction is inside of here. So the idea is that if I didn't have a calculator, I could rewrite 59 as something plus something or something minus something, and then I could do the distributive property. So I could do 55 plus 4, or I could even easier is 60 minus 1. And then the distributive property says, okay, I'll take this times this, that's 300, minus this times this, that's 5. So I get 295 quickly. So if you don't have a calculator handy, this is a really good way to find easier ways to multiply using the distributive property. In this one, maybe you could do 30 plus 3, because 8 times 30 is 240, and 8 times 3 is 24. So you very quickly could get that your answer is 264, even without a calculator. So these are some tricks to doing math without a calculator. On your worksheet, here's a review. This is the top part of the worksheet. It reminds you about the commutative property. One way to remember that is commute is to go back and forth to work usually, but that means that you can change the order. So commutative is like going back and forth. Changing the order back and forth is okay. Associative, there'll always be, the grouping will change. So associating is with a group, and changing the group is okay. Distributive property, you're spreading something out. You're taking this 2 and you're distributing it over the 8 and the 3. So 2 times 8 plus 2 times 3. Here's some review too of some problems with commutative, associative, and distributive property. And then on your worksheet, these are your problems to do. So you're going to use those properties to try to mentally solve these problems, to try to put them together so that you can do them in your head. And you, of course, can check your work with a calculator. So I would put the 8 times 5 together and get 40, and then I would do the 40 times 3 and get 120. In number 2, you have to do the distributive property first. This one, we're just going to be able to simplify. We're not going to have a nice, neat answer. So 2 and 3 are really just practicing doing the distributive property. We'll look at those more in the next section. Let's look at number 4. 4, let's put the 7 and 3 together. That's 10. 7 plus 3 is 10. Plus 36, that would be 46. Let's do 7. If I rewrote the 30 as 30 plus 2, then you could take 6 times 30, which is 180. And you could take 6 times 2, which is 12, and then you could figure out what 180 plus 12 is equal to. Okay, then the next section we're going to talk about is like terms. Like terms are terms that have the same variables raised to the same power. It has to be the exact same variable raised to the exact same power, same exponent. Constants are also like terms, like 3 and 5 are like terms. So in this example, the 4x and the 3x, those are the same variable, or x and x. Neither of them have an exponent on them, so these are like terms. The number is called a constant. When there's no variable on it, it's called a constant. The way that we combine like terms is you look at the coefficients. The coefficients are the numbers in front of the terms. So this coefficient is 4, this coefficient is minus 3. And we would combine those in order to find our like terms. If there is a variable that does not have a number in front of it, like x squared plus 3x, then you can put a 1 there. The coefficient of any variable without a number in front of it is 1. So the way that we add like terms is you only look at the coefficients in front of the like terms. So we have a 7 and we have minus 4, which is 3. So this would be 3x squared. The variable and the exponents stay the same when you combine like terms. So here we have 72p minus 25p. Those are both like terms because they both have the variables p, no exponent. So we just have to subtract the 72 minus 25 and get 47, and then we write the p down. The p doesn't change. In this example, we have 0.5m plus 2.5n. One's m, one's n. These are not like terms. So you would just write the exact same thing down. The answer is that there's nothing you can combine, so the answer is 0.5m plus 2.5n. All right, let's look at some more examples. In 3a, we have 16p plus 84p. Since those are like terms, we can go ahead and add the 16 and the 84 together. And when we do that, we get that this is equal to 100p. In 3b, we have negative 20t minus 8.5t. Those are like terms because they both have t for a variable. And then we take the negative 20 minus 8.5, be careful there, and you get negative 28.5t. Now look at c. We have 3m squared plus m cubed. I said that the definition of like terms was that they had the exact same variable raised to the exact same power. One of them's m squared, one of them's m cubed. Those aren't the same, so these are not like terms. So our answer is just to write that again. You can't simplify any more than that. So on your worksheet for 9, 10, and 11, you just have to say yes or no. Yes, they're like terms, or no, they're not. You might wonder about 9. Sometimes your like terms will have more than one variable. xy and xy are both the same, so these would be yes. Number 10, one of them's squared and one of them's not, so what do you think? And in 11, one's a and one's b, so what do you think? Okay, so in 12, we have 7st minus 3st. They both have the variable st. So these are like terms, so then we just look at the 7 minus 3, and that's 4, and then we just write the st after it. In 13, we have y cubed, and then a y, and then another y cubed. These two are like terms, but not this one. Note that the minus sign in front of this term goes with that term. So when I'm combining my like terms, I have 10y cubed minus 4y cubed, and then I'll just write the plus 5y. These are the two that go together. 10y cubed minus 4y cubed, you just take the 10 minus 4 and get 6y cubed. Don't change the y cubed. And then you just rewrite the 5y after that. That didn't have anything to go with, but you still have to write it down as part of your answer. If there is no like terms, then just rewrite the problem. Remember that when you're typing on a keyboard, you can use this key to mean that there's an exponent coming. So 12x cubed, you'd write, oops, I forgot the x. You'd write 12x, and then this means that there's an exponent coming, so 12x cubed, and then plus. In 15, there are some like terms, so combine the ones that are like terms. Remember to combine the coefficients in front of, and then just write what you have left. Okay, sometimes we have to do the distributive property while combining our like terms. So before we can find out if there's any like terms, we have to do the distributive property. So we're going to go through this really step by step. This is a proof or a justification of each step. So we would start with just our given problem. We write that down. And then what we're going to do is the distributive property first. And when we do the distributive property, we take 4 times 2, and then we take 4 times x. Then we simplify, and we go ahead and figure out what is 4 times 2, and what would 4 times x be, and we just write our simplified answer there. 14x plus 8 plus 4x. Now we're going to see if we can rewrite this so that our like terms are next to each other. So 14x plus 4x, now our like terms are next to each other. We use the commutative property to do that. Now we'll combine, now we're going to group those together, the like terms together. Finally, we will go ahead and combine our like terms and get 18x plus 8. Now when you're solving your problems, you do not have to write all of these steps and you don't have to do the justifications, but it's kind of nice to see how what we're thinking in our head, you could actually step by step label each of those steps and say why it is that we're able to do that. Let's look at number 17. So we start by looking through, and what we're going to do is the distributive property first right over here. So we're going to take 2 times y, and then we're going to take 2 times negative 5. So I rewrite the 7y right below it. Then I multiply 2 times y. Then I have a minus sign here, so you write minus here, and then 2 times 5. So that's the distributive property there, and then the plus. I'm going to put a 1 for a coefficient in front of the y term. If there's not a number in front of a variable, you can always put a 1 there. Now we do the multiplication. 7y plus 2y. 2 times 5 is 10, and then plus 1y. Now finally we go and look for like terms. If you want, you can rewrite this so that your 1y is next to your other y's. So 7y plus 2y, that's the commutative property that lets us do that, plus 1y. Remember the sign in front of the term goes with it, and then the minus 10. So my like terms are all the ones that have a y in them. So we have a 7y plus 2y plus 1y. And we add that up, add the coefficients. 7 plus 2 is 9, plus 1 more is 10. And don't forget to write the minus 10, the constant, at the end. And it's all solved. Now, these can't be combined because the second one is a constant. It doesn't have a variable on it. All right, let me know if you have any questions. Have a great day.